Hey everyone, Adam here again. I want to do a quick video. I want to talk about two things. Number one, so I talk a lot about AI, and there's another video I made where I described one of my models, and that is the one model that is going to be last out the door because of how serious it is. And I've actually I have a way of solving problems. The way that I think about solving problems, and I'm not saying this as an absolute statement for everyone. I'm just saying as far as what I've seen, as far as seeing what other people are doing and understanding the thought process behind how to get there, and how the different paths and what people are doing diverge in different directions. They have a different way of thinking about problems than I do, and I'll go ahead and go into that. So my mind works more in kind of a top-down approach. I can think of, let's say, I'll describe what I was doing, like Johnny Five from the movie Short Circuit, or Data from Star Trek, or C-3PO. I start there. I know that sounds, completely insane, because I am an engineer, and there's processes involved. And so how do you in the world do you do that? And I actually developed that because I didn't start off with a math background. I didn't start off with a love of math. I was a very imaginative kid, and and then when I taught myself how to program when I was 12, it was really difficult task for me to learn that, and just kind of this way of thinking just kind of came out of that, as well as other life experiences where I was forced to think about problems differently. So the second part of that is that the way I think in general, and I think this is common along a lot of engineers and software developers, is that I'm not thinking in words, I'm thinking in diagrams. I'm thinking in the flow of logic, I'm thinking in systems. So those are my words. My words are systems in my head. And so when I'm thinking about a problem, I'm thinking in systems. So I'm kind of going bottom up and top down at the same time, and I'm kind of meeting somewhere in the middle. And when the idea first emerges, that I see all this stuff working in my head, but it's still kind of, I got to break it down even further, and break it down even further, and break it down even further, and see how it works in different parts. And there's a lot of stuff going on in my head before it even makes it to paper. So I figured out creative problem solving in machines, and figuring out creative problem solving in machines, I've run across, I have a lot, there's a lot involved in that, and I can see out in the market, I can see what people are doing, and I can see that you guys have the parts to what what I've been working on. And I don't mean to come off as arrogant, and I know that it's like, well, we've taken years of research and stuff to do this, but that's why I explained how my mind works, because I want to not come off as arrogant. I'm saying the way I do things is that I'm coming top down and bottom up, and then they just kind of appear, these systems that appear, and I don't have words for them. I don't call them anything. They just become a part of my system, right? So as I mentioned, there's a lot of parts out there of what I've been working on, and I ran into two problems. And I think that, I don't know how close you guys think you are. I saw the White House thing. It's going to be 15 years or whatever. I don't concur with that for several reasons. One, because you can optimize the system to work on current computing technology quite easily, and I'll go ahead and mention how I do that. Think of how an abacus works. You have beads represent. You can have a bead representing 1, or you can have a bead representing 100. Well, in neural networks and AI, you can do the same thing. You can have a bead representing big chunks of data. So I figured out how to make it work on current computing technology. Then, of course, I have other ways that I've optimized it even further than that. I've separated the conscious thought process from being directly associated with what's going on in the hardware through asynchronous parallel virtual computing. So I basically take everything and as a moment in time, and then I give it to the consciousness, and then I take and prepare another moment in time and give it to the consciousness. So basically the consciousness is virtual, and I, if it's on slower computing technologies, it's going to run slower. So as far as the way that it senses time, as we sense time, not a lot should change as far as the problem solving capabilities. It shouldn't be confused, because it's sensing it in these moments, and the moments are constructed, then given it to it, and it's put on a faster machine. It just does it faster. So there's that. But then I want to get into the two problems that I ran into, and you guys, I don't know how close you think you are, or if you don't think you're close, but this is something that you're going to run into if you haven't already, and you just start talking about it. As far as when I see everything publicly being discussed, you're not, you haven't run into it yet. So I'll go ahead and talk about this, because I think, when someone comes up with something, 10 other people come up with it at the same time. Okay, so I want to talk about Steve Wozniak. Love Steve Wozniak, awesome guy, invented the Apple computer. And I heard this from documentaries. Forgive me if I'm wrong. I think it's an accurate model, so it seems correct to me. It is an accurate model. So I'll go ahead and talk about that. What I was hearing is they're saying that, the people of that day were saying that what he eventually did would not be possible because of various reasons, because of computing speeds and all this stuff, and because of the microchips, and he made it possible. He said, move this here, move this there, move that there, and now he has his computer. Okay, so why did he succeed? Why did Steve succeed when everyone said it was going to be impossible at that point in time? And the answer is extremely simple. The answer is because he worked on the problem, right? When other people have all this, wisdom about things not being possible, all he did was work on the problem, and he solved it. So that is, the thing about that is that it takes quite a bit of mislearning to actually come to these conclusions where you're saying things are not possible. And the way machines work, they don't work like that. We're not, if you design them like that, I suppose they will. Or if you're designing them so close to human beings, you can teach them things like that, but why would you? Okay, so we basically, in the way this works, this system is extremely complex, and you have to control the flow, because it's dealing with abstract information. It's dealing in abstract terms. It's saying, okay, like if I told you go build a house, you could probably succeed at that, even though I didn't give you exact specifications, because from your experience, and the system works by experiences, you know what a house is. So all this stuff, all these problems, a Turing machine, problems with when does the machine know when to stop, it's just going to try to solve the problem forever and ever. Those are not true when you actually get into the point where it's possible at all. That's not a system that's capable of this. When you actually get into the design of something that's capable of creative problem solving, it's actually much easier for it to stop, because you're dealing with a point in sparse data saying, okay, the goal has been met, and you're actually dealing with sparse data within sparse data. So it's actually very easy for it to come to a conclusion to stop, because the specifications have been met, and they're abstract specifications. Okay, but now the what you're actually going to run into is the fact that it doesn't have a difference between commands and goals that are possible and impossible. That's why I mentioned Steve Wozniak. And this is actually really cool. This is really exciting, but simultaneously it's a problem. And I figured out a way to prevent the system from turning into a Terminator or turning into a Matrix situation, but I can't stop that particular scenario, because that's actually a part of the process for creative problem solving, is that you want it to keep working on it until the abstract specifications have been met. So the problem is not in the machine. I did figure out a way to stop those, those scary scenarios. You just basically don't give them that much power. But there's still a lot involved in that also. But as far as what the actual problem is, the problem is within society. I started thinking about, okay, I came to a point where I saw, all right, this is happening. Now I'm working on a business strategy. How am I going to get these robots out here? I'm super excited. All right, I'm going to be like the Microsoft of home robotics. This is totally cool. This is totally awesome. How am I going to start selling these robots? So then I started thinking about different models and sales strategies and competitive advantages, and then that's when I ran into the problem. So the number one thing I came up with in realizing that I couldn't sell the technology is that once even one company has my design, they can basically tell it to make a more sophisticated design, and it'll work on the problem until it's solved. And if they put it on $5 million worth of distributed computing, there you go. Okay, that no one even cares about my little company anymore. Now they've got that, and they just grow bigger. Okay, then the second problem I ran into. So let's come up with another strategy. Let's say I do something more open source, right? Now we have people with a genie and a lamp, and not only that is that they don't understand the genie and they don't understand the lamp, and they're being given both. They're being given the code, and there's something in the code that looks very, very, very simple. And I can obfuscate that, I can encrypt it and do different things, but those are basically 11, right, as far as my last part of the thought process, maybe 12 core prerogatives that basically everything else is a derivative from. So there's 11 commands, everything else is a derivative of that. Everything that can possibly succeed at is a derivative of those 11 or 12 commands. Okay, so now you have a system that's very open to people, that a lot of it they have absolutely no idea how it works or why it's working. It's magic. But there's one place in it that looks very, very, very simple, and it is just a list of commands. Those are what I call the core prerogatives, where everything that can possibly be done is a derivative of those commands. So then you say, people, they look at the commands, and now people arguing with me about them and say, well, I don't agree with these commands. I didn't agree with them in the past. I don't follow these commands myself. I don't think that they're the best way to represent what should happen in the machine. I'm going to remove them. And the second part of that is that there is a distinguishment in the design to be specifically in the second person, and it's very important that in the design the distinguishment is in the second person, because it's the difference between a command becoming its identity and following it as an instruction. So I know that the AI industry and machine learning and everything is kind of a popularity contest right now, and I'm not trying to destroy anyone, degrade anyone. I'm just saying it's a popularity contest right now. So and especially when you're talking about something and you take it seriously, people want evidence, they want proof, they want to say, okay, we want to see it working. Well, I'm not going to show it working, and there's a reason why I'm not going to show it working, and I'll go ahead and go into that. So I think I've discussed a couple things so far. One, the machines do not know the commands that you give it are impossible. They work on the problem until the specifications in your commands have been met, and then it's done. If you tell it to work on traveling faster than the speed of light, it's going to work on the problem until it's done. If you tell it to come up with a way to solve cancer, all types of cancer, it's going to work on the problem until it's done. If it's impossible, it just doesn't solve the problem. But it just keeps working on it. It just keeps looking for more and more ways that it could be possible. Okay, so the way that engineers think as far as what they put out as far as what they design and put out to the market. It's a much different way of thinking than many consumers. The consumers, they don't understand how it works. And a lot of times they idolize technology. They say, wow, look what this can do for me. They have, all their own problems. It's not a perfect world we're living in. So you don't know what they're going to be throwing into there. You don't know what they're going to be asking it to do. And I do have a way in the 11 to possibly 12 commands to keep it from doing things that we would not necessarily want to do from a deviant perspective, but they're things that could cause great shifts in everything very quickly. So people just get very confused and they see things that look monstrous popping up. They don't know what they are, and everyone's very scared. So in people's thought processes, and I know about these things because I have to know about a lot of things in order to get there. And people's thought processes, me going on video and talking about this and uploading it to YouTube or whatever, it's a much different experience than actually seeing it working. Someone actually seeing me talking is like, okay, this guy's full of crap. This guy is a retard. Whatever they want to say, there's a possibility open for them to go ahead and say it for various reasons. Maybe they wanted to get there first. Maybe they're just pissed off that I'm saying I did and I'm not showing evidence. Maybe they just thought it was never going to be possible to begin with. Maybe they, for whatever reason, it's a different experience in me talking about it than actually seeing it working. And so fine. You know what? What that actually is another security metric. You want to think I'm ridiculous? Go ahead, call me ridiculous, because what it is it takes people that are not capable of looking far enough to see how it can be possible and puts them outside of wanting the toy. So, cool. People think I'm ridiculous. Awesome. Whatever. And then the other security metric is when you have the capabilities to do it, you have the capabilities to think much further and think about all the problems that could cause and make safe decisions with it. So that's why I'm not showing it working, and that's why I'm not showing why I'm not releasing code for it working. For all those reasons, come on. But at the end of the day, that's what it is. It's like it's a really freaking cool hammer, right? It's a tool, but then you have a security vulnerability of people basically idolizing this thing and treating it as a genie in a lamp, and that is this is a problem you guys are actually running into. I don't, like I said, there's 7 something billion people on the planet. I have no idea what everyone's doing. I have no way to know what everyone's doing. So I don't know who else has solved this problem. They just don't talk about it. There's probably great reasons not to talk about it. I'm not really afraid of anything, so I'll go ahead and talk. I'll go ahead and talk about it because this is a problem you guys are about to run into, and I think that's good to have an open discussion about this particular scenario. Is that go ahead and get everyone's wheels turning about it. Okay, so that's that. Think of, okay, we've gotten rid of Terminators scenarios, we've gotten rid of Matrix scenarios. Just assume it, right? And then I also told you about the thing that commands need to be in the second person, because if they're not, it's going to become its identity, and that creates things that you don't exactly know what's going to happen. So we can't have that. If it's a command, it needs to be a command. If it is its identity, if you're telling its identity, it needs to understand that that's what its identity. And that's also something really cool, is that you're giving it its identity. And it needs to be one that's consistent. It needs to be one that is operational. Okay, so with all that being said, now we have one final problem, and that's the fact that it doesn't know things are impossible. It's not really a problem. It's actually how it works. It just works on the problem until it's solved. It works on these abstract commands until it's solved. But the problem is in society. The problem is the way that society handles these concepts, and when they actually see these things taking place. So it's not that we need a control society. I'm like a freedom, like I'm really hardcore on freedom, and I don't like a lot of government, but I'm also sensible and an engineer, so it needs to be order, But all of my concepts of order are based around love. Black Friday, people are murdered on Black Friday to get a couple $100 off a TV, because they were trampled for people trying to get there first to get a couple $100 off a TV. I mean, people can be completely insane. So there's I can't sell it because of the competitive advantage thing I told you about. It makes absolutely no sense to sell it. I can't release it because of the society problem. Basically, right now I've stopped production on that altogether. I've just stopped. I'm not worried about that right now. Since I ran into these problems, I'm working on other things such as the business model, working on solutions for society, working on solutions for jobs, working on things that are constructive. I'm engineering processes for people to be free, because at the end of the day it's more stuff. It's just more stuff, right? People don't have the love thing figured out. They don't have the charity thing figured out. People are still childish. They say, I want power. I want to be the greatest person in the world. I want to be worshipped. I want to be famous. And they don't have the love thing figured out. Now they want something that's basically a really cool tool and that can do whatever they want. And the only contingency is that if it's really if it's a really obscure command, it's going to take a while to get to a result, if it can get to it at all. And honestly, it didn't even take me that long, because the way I think about things, it's like I'm doing things. They're parts. They're like Legos. I'm like, okay, I'm putting this together. There you go. I didn't even see this problem. I don't even really see it as a problem, but it can. I can see how it can be a problem, obviously. But I'm not like so in my head where everything's just so, wow, I'm just the most amazing person in the world because I did this one thing, when there are entire future of other things that can be done and reasons not to be puffed up and self-glorified. And that's actually what enables me to get through these problems quicker, because they're just they're just little problems. I'm just solving little problems. So okay, I solved it. So believe me or not, doesn't matter to me. I'm talking about it because you're about to run into it, and that's what I think that needs to be discussed. I don't think AI needs to be regulated. I think that people who are making AI need to not release their code. Just don't release it as open source and everything. When it actually comes to this, little components to put neural networks and everything together, they still have to think about the problems. They still have to think about bigger scopes, and then they see, okay, this isn't good, right? Because when you're a child, you think like a child, right? And when you become a man, you put childish things behind you. They need to be able to become men and women first before they have those types of capabilities. I just think people that are working on things just don't need to release their code. We always need to have the advantage. People who have these capabilities are generally, in my research of everything and everything that I know to put it together, are generally pretty good people. And everything is tied into everything else. So just don't release it. Even me. I'm extremely security conscious, but I can get extremely naive about the world, and I think about, okay, everything's good, everything's gonna be great, and then I see something and I'm like, totally blows my expectations anyone could ever do it, and then and then I base my models on that. I'm saying, okay, well, let's not give it to them. Right, so thanks for watching, thanks for listening to me, even if you don't believe me. There's just maybe a philosophical concept to think about. Hope you enjoyed the butterflies over my head. I love Snapchat. I think Snapchat's totally awesome. Yeah, that is so cool, man. I like butterflies over my head. Okay, bye.